Welcome back. This is video 5 or lesson 5 in making schematics and PCBs with KiCad. In this lesson, I'll explain how to do PCB layouts. So when we left off, we had completed our schematic in EE Schema. We'd assigned footprints to every schematic symbol. We'd done an electrical rules check. We generated a net list with all the linkages between components. Now we're ready to generate the printed circuit board design. That's done with this program called PCB New. So again, the icons across the top menu bar are kind of in workflow order. So we can either click on Run PCB New here, or in our project manager, we can click on it right here. Either one will start the PCB New program. So this is the layout. We can zoom in again by the scroll wheel. Across the top are menu buttons again in workflow order. Most of our buttons for generating the PCB layout is going to be on the right side. Here's the layers manager. If they're checked, that means we're using that layer. The little arrow points to the layer we're currently working on. You can change that here by clicking on the layer, or up here in the layer box up at the top. The layer that's currently selected is the front copper layer. If I hover over it, just below it is the back copper layer. Other boards might call it the top and bottom layer. If you uncheck them, then that's not going to be visible for working on. All right, before we start setting up our board, we need to define how we want to do that. We can do that in this board setup menu in the top left side of the screen, or we can go to File, Board Setup, either one. This is going to set how many layers on our board, how thick we want our board to be, all of the rules for the board. I'm going to select, this is the simplest board possible. We're going to have we'll have 2 copper layers, a top and a bottom, or front and back as is set in KiCad. And we can set the PCB thickness of the board. I wasn't sure on the thickness, so I went and measured the board I'm going to be using. Looks like about 1.5 millimeters thick. I looked up on the internet standard board thicknesses, and it reported on the internet several places as 1.57 millimeters thick or 1.6 millimeters. So this looks correct for my board that I'm going to be using. At the left side, none of the tracks or vias are set yet in the settings. Let me explain what tracks and vias are. The track width is just the width of the solder run that you're going to have printed on your board. So the width right there. A via is used in cases like this. This is an old printed circuit board made by hand that I did. And you notice how sometimes there's so many copper traces on one side of the board that you can't run across them because that would connect runs you don't want to connect. For an example like this, I needed a wire to go from this trace, you can see through the transparent board to the other side where the copper run is, to connect to this trace. But I can't run on top of this trace. So I had to use a jumper wire on the other side of the board. You can do those jumper wires on the same side as the components. So those are called vias. You're going to go from some trace to another trace via a jumper. So we need to specify the widths of the tracks or traces that are allowed and the vias. So I'll start with 1.5 millimeters as a width. You can just go and enter each one. 2.5 millimeters. You can just add them all. The same for the vias. I can go over to that column, hit plus. I'll make my first one say 2 millimeters. Now the drill size is the hole that you're going to use to connect that via, so I'll say a 1.5 millimeter hole. Rather than take time every project to type these tracks and vias and all these board setup settings in, you can import them from a previous project. So I'll go ahead and show you how to do that. You can select all the things you want to import from a template, select all of my settings, and there they all are. So we hit OK and we're ready to go on. Next thing is, I don't like the color scheme that we're using. This dark red on a black background is hard to see. Go over here to the right hand menu, select items, go to worksheet, see the dark red color. I'm going to right click on that and change my color for that worksheet. I'll select this kind of manila color, and it's much easier to see. Next I want to go to the page settings. So go up to File, Page Settings, and that will allow me to put the date in, revision. So I'll say this is revision 1.1. A title for my project, we'll call it Continuity Tester. Company you work for, I'll put myself in as the developer and hit OK. So now it's easier to see on this black background. The next thing we want to do is enable the layers we want to work on and disable the layers that we don't need. Again, this FCU is the front copper layer or the top, the bottom copper layer or the back. We don't need adhesive layer, paste. This F silkscreen, the silkscreen on the board's front. Let me explain what that is. Here's a picture of a board. The silkscreen are these white outlines that are printed on the top of the board, and the numbering, the lettering, any information you want people to know. The outlines of the components, like these squares for each resistor, the shape here that outlines a capacitor, this semicircle for a transistor. These kind of silk screens can help you assemble your board and know where the components are placed. So that's called the silk screen layer. It'd be good to leave that layer on in our PCB new program. So we'll leave the silk screen. The solder mask we could leave on, but the back mask we'll turn off. We don't need these other settings. The edge cuts, that's important to leave on. That's the perimeter of the board. That defines how large the board is and the shape of the board, so we'll leave that on. We do want the footprint courtyards. What that is the area around each component's footprint to prevent us from putting components too close or on top of each other. So let's leave that board front footprints on. We don't need the back or this fabrication. So now we've selected the layers that we want available to work on. The next step is to define the size of the board we're going to use. To do that, we need to work with the edge cuts layer. So I'm going to click to the side of that edge cuts layer. Notice how it moved my arrow down, so that's my selected layer. Now we need to draw the size of the board we're going to use. I'm going to use a board this size, so I just took a ruler and measured it both in inches and in millimeters. Looks like 3.25 inches, 3¼ inches, or 83 millimeters. So now we go over to the Add Graphics line tool. I can click anywhere on the board, start dragging the line. Notice the length in the lower left corner. It tells me the length in millimeters. I wanted it to be 83 millimeters. We can go with 82.55 millimeters. Close enough. The width of my board is about 57, 58 millimeters. So make sure you straighten that out. 57.150. Click there. Go back over to your starting position and back up to my beginning. Now I have my rectangle for my board, and I can zoom in on that area. And I'll click on the select item icon so I don't draw anymore. Now the next step, we're finally ready to use our schematic to import the correct components onto the board. So we can do that in two different ways. Up here on the top menu bar, I can either click Load Netlist or Update PCB from Schematic. For the first layout, I'll just click on Load Netlist. Back when we finished making our schematic in EE Schema, we saved a netlist, so it's going to use all that information to populate our board. So we need to just tell it where the file is for that, and then there's a bunch of options we could use, but we'll just go with the default options to begin with. When I click there, I'm in my continuity tester folder, so there's our .NET. I'll click on that and click Open. And I'll click Update PCB. Yes. And here's all my parts. I can move them around to put them on my board. So I'll just click there, and there they are. Now it's a matter of rearranging them on the board to where we want them. So I've zoomed in, used the mouse scroll wheel to zoom in. It shows my board outline for the size of the board. Now I can just move each component. If I hover over a component, click on it, and use the hotkey M, it allows me to move that component. R, the hotkey R, allows me to rotate it. So I can move, say, my battery connection over here, click to place it. click and move my test point, you do have to be careful to click on the component itself, not one of the lines or pieces, and move only a footprint. I find it easiest to move things out of the way to begin. So I've moved a few pieces around. It's just a matter of deciding where you like the layout. If you want to move multiple pieces at the same time, click and drag the mouse over the bunch, then hit the hotkey M, and you can move the entire selection. So then click anywhere outside and it will set them in place. The lines show the electrical connections between the components, but they don't show where the traces are going to be. You're going to need to lay out the traces and vias later. So for now, I'm going to leave this positioned where it is. If I decide later I want to move it, that's fine. You can move things around later. Also, if I decide that the footprint that I've assigned for a component isn't really what I want, you can change the footprint in PCB New, but I would recommend changing the footprints in EE Schema and then just clicking this button to update the PCB from the schematic. Otherwise, you'll have problems with back annotating into EE Schema from PCB New. So it's just easier, in my opinion, to just switch to EE Schema and then make your changes, then update the PCB from the schematic. We'll end here and join me for the next video on how to lay out traces and vias.